So the question asks, if x is greater than 3, which one of the following four options is equal to, equivalent to the expression that they give us at the top here. The most efficient way to do this is to manipulate the expression at the top and see what it comes out looking like, compare it to the four options, and hopefully it will look like one of those four options. So we'll start now. So this is 1 over. Now the problem is we have different denominators here. We've got x plus 2, we've got x plus 3. So we'll write this as a common denominator. So something over x plus 2 brackets x plus 3. Now I multiplied the denominator by x plus 3 here. Originally it was just x plus 2, but now it's x plus 2, x plus 3, which means to make it fair, to make it equivalent, I have to multiply the numerator as well by x plus 3. Plus something over x plus 2, x plus 3, and in this case the denominator used to be just x plus 3, but now it's x plus 2x plus 3, which means we've got to also make it fair and equivalent by multiplying the numerator by x plus 2 this time. Just to convince yourself that these are the same things, they're equivalent, we could just cancel out the x plus 3 to leave 1 over x plus 2, just like over here, and we could cancel out the x plus 2 to leave 1 over x plus 3, just like over here. So these are equivalent expressions at the moment. Okay, we can simplify this. This is equal to 1 over. We could combine together the fractions now because they have a common denominator. That was the whole reason we did it in the first place. So we can say this is equal to 1 over 1 brackets x plus 3 plus 1 brackets x plus 2 all over x plus 2, x plus 3. In my next line of working, I will just expand out the brackets. This is equal to 1 over, we can call this 2x plus 5, just by adding together the x and the 3 and the 2, all over, expanding the double brackets gives x squared plus 5x plus 6. Now I can write this in a more convenient way, so I can write this as 1 divided by 2x plus 5 x squared plus 5x plus 6. Here I will use the keep flip change method. I'll keep the 1, I'll change the divide into a times, and I'll flip the fraction to make it x squared plus 5x plus 6 all over 2x plus 5. And then we could just ignore that 1 times by, just to leave it as x squared plus 5x plus 6 all over 2x plus 5. That's the final answer, and that is option number, or option letter B. So that's the answer. Now we can convince ourselves that is the correct answer by substituting in a value for x. It has to be a value greater than 3. So I could pick, for example, x is equal to 10, sub it into what I've got, sub it into what they gave us at the start, and it should yield the same answer in both cases. So if I plugged in x equals, let's say, 10 into the first expression, so 1 over 10 plus 2 is 12, plus 1 over 10 plus 3 is 13. Let's get a common denominator. 12 and 13 both go into 156, so I can write this as 1 over, to multiply 12 into 156, I have to times it by 13, so I times the numerator by 13 as well. To make 13 into 156, I have to times the denominator by 12, so I times the numerator by 12 as well. I can write this as 1 over 25 over 156, which is equal to 1 divided by 25 over 156, which is equal to 1 times by 156. This should be 156 over 25, which is 156 over 25. So that's what I get when I plug in 10 into my original expression. Let me now plug in 10 into the thing I think is the answer and see if we get 156 over 25. 10 squared is 100, 5 lots of 10 is 50, plus 6, 10 lots of 2 is 20, plus 5. 100 plus 50 plus 6 is 156, 20 plus 5 is 25, and these two things are equal, therefore our answer of B is correct.